Laws of exponents dividing monomials, lesson 4.3 notes. Example number 3. The volume of a cube is given by the formula V equals S cubed, so volume equals side length cubed. The surface area of a cube is given by the formula SA equals 6S squared. In other words, surface area equals 6 times the side length squared. Find the ratio of the volume of a cube to its surface area. So we're going to find the ratio of the volume to surface area. As the length of an edge of the cube increases, does the value of this ratio increase, decrease, or stay the same? Well, the first thing we need to do is find the ratio. So the ratio they say is volume to surface area. Since they said volume first, that would go in the numerator, surface area would go in the denominator. So we're going to put volume over surface area. Good enough. All right. The volume of a cube is side length cubed. The surface area is 6S squared. So I'm going to divide this. Well, the coefficient in the numerator, you don't see one, would technically be a 1. Well, 1 over 6, if it's a 1, you can't reduce any farther. So it's going to stay 1 over 6. So in other words, I don't need that 1. The only thing I need to do is divide the s terms. So s to the second has this smaller exponent. It would completely cross out. And 3 minus 2 is 1. So volume to surface area would equal S over 6. So side length over 6. There we go. I'm trying to make it not look like a 5. So side length divided by 6 would be your ratio of volume to surface area. Well, that's the first part of this question. The second part says, as the length of an edge of the cube increases, does the value of this ratio increase, decrease, or stay the same? So as s increases, what happens to that entire fraction? Well, let's use some examples. So we'll use, since the denominator is a 6, let's use numbers that are divisible by 6. So 6 is divisible by 6. We'll use, how about 18, and then 30. All right, so first one, if I plug that in for s, that would be 6 over 6. Well, 6 divided by 6 is 1. The next one, I would plug 18 in for s, so that would be 18 over 6. 18 divided by 6 is 3. The last one, I would do 30 over 6. 30 divided by 6 is 5. So let's look what happened here. As these numbers increased, what happened to the value of the fraction or the ratio? Well, to start with 6, I got a 1. But then when I increased it to 18, it did what? It increased to 3. As it increased to 30, it increased to 5. Therefore, as the side lengths increased, as those numbers increased, the ratio also increased. So as the edge length, or the S, increases, the ratio of volume to surface area also increases. Pause your video and get that written down. Okay, if you have any questions on example number 3, please make sure you have everything written down. If you have any questions on example number 3, please let me know.